host, Dr. Sam.
Hello and welcome to the Emerald Planet as we come to you looking in 144 different nations, looking for those 1,000 best practices, the technologies, the services, and the products that are making a difference as we move through the 21st century. And again, as we add 2 billion new souls by 2050, how we're going to be able to provide the energy needs for these so that actually are productive human beings, and at the same time to bring a comfort of life, a quality of life that in many of the countries, say in Africa, Southeast Asia, even South America, are not realizing at this time. So as we add these people, how we're going to be able to absorb and provide all the basic needs. We have a gentleman who is creating new technologies that's actually getting at this. This is Dr. Richard Joseph Roby. He's a professional engineer and president, CEO of what's called LPP Combustion, LLC. And Rick, welcome back again.
Sam, good to be here again.
And I know that you've been working nonstop on the technologies you have, but what is LLP combustion?
LPP combustion, basically what the name stands for is lean pre-mixed pre-vaporized combustion. That's a kind of combustion that allows fuels to burn as cleanly as it possibly can, providing the cleanest energy with the least amount of pollution.
Well, looking at that, and we have this fantastic photograph that we actually took off the internet, geology.com, and this is actually talking about one of the areas where there's a major fracking area. But you and I are going to be talking about the other F of this is flaring. So what are we looking at here? I understand this is like 200 miles long by 40 miles wide. That's a huge area.
Yeah, this is the Eagle Ford area of Texas, which is one of the big major fracking fields in the United States. And what you can see from space is the light of all the fracking rigs and all the flares that are being used to flare the gases that can't be properly harvested and used at the well sites.
Now looking at this, let's bring this up if we can, the photograph in full light so we can see this. So we see this huge long stream. As I was told, it was 200 miles long by about 40 miles wide. Why are we taking a precious natural resource, fossil fuel, and then we're just burning it and putting it to the environment?
Well, the problem is that there are two products that we're usually going after when we go through fracking. One is natural gas, which is primarily methane, and the other is a form of crude oil that we can then ultimately produce into gasoline and heating oil, jet fuel, all those kinds of things. The problem is whether you're going for natural gas or for the oil, there's some hydrocarbons that sort of fit into the cracks between them in terms of fuel, and they don't work very well in most combustion systems. So since that's not really what we're trying to harvest, it ends up being sort of a byproduct that there's no immediate use for, and to get rid of it, we flare it.
Okay, but this is becoming a big no-no around the whole globe as far as environmental change is happening at a very rapid rate. And at the same time, my understanding it's over $100 million per month, I think is what the research said, of natural gas being flared in the Bakken shale oil deposit area. You know, that's a lot of money.
Correct. So, I mean, just in the Bakken field in North Dakota, about $100 million of hydrocarbons per month are being flared. And so not only is that causing pollution, it's causing the light that you see from outer space, but it's also a wasted resource.
Well, looking at it, and I know this goes to the heart of your technology, and we have these different flames here and the heat that's being used, and also actually the amount of waste that we're actually providing, I guess, to the environment by not being able to very efficiently burn and use the fuel that we're bringing up.
Correct. So right now, most of the fuel that's being used for fracking is diesel fuel. And diesel fuel is burned as a spray liquid, if you've seen an old oil burner, and it's kind of like the orange brushy flame that everybody's used to seeing, kind of a candle flame. That flame is very polluting. The natural gas flame that people like, the nice blue flame, is actually very clean. And so the flares that we see are indicative of that dirtier kind of flame. And what our technology does is it takes the kind of liquid gas mixture that's not readily burned in any conventional engine and converts it into a natural gas substitute that can then be burned in gas turbines as cleanly as natural gas and give us that same blue flame instead of the dirty orange flame that's coming off the flares.
Okay, so we have the solution that we're looking at right here. We're going to go back to the problem, of course, that we're looking at here. So how then does LLP combustion match the problem that we have, that we're seeing from these satellite photographs, in order to get over here so it can be used, but it's used for something that's very beneficial to society, reducing the impact on the environment, but also providing more energy efficiency within the economic system so that people can produce goods faster, better, and less costly.
Yeah, so it provides both economic benefits and pollution benefits. So if we stop flaring those gases and burn them much more cleanly, but not just to burn them, for power generation, our technology would allow you to take those flared gases and liquids and burn them for gas turbine power to produce electricity that can either be used at the well sites to power the wells instead of the diesel engines that are much dirtier, or to put extra power on the grid that can run households or businesses.
Well, looking at this this diagram here, what are we looking at? We know what the flare looks like. We see the wellhead over to the extreme left of this, and then we want to be able to make use of this both within the operations, the fracking operations themselves, and to use in the general society. So how do we match that up?
So what we can do with our technology, we can take those gas-liquid mixtures that are currently going up in smoke, literally, in the flare, and put them through our LPP combustion system. It's a fuel processing system that takes those, mixes them with nitrogen, and converts them into a gas that to the gas turbine looks just like natural gas. And so it burns just as cleanly as natural gas and produces electricity just like natural gas. So instead of going up in smoke, we literally get very clean power.
Now, looking at this, we're saying that it's over 100 million per month natural gas being flared up in the Bakken, but you have this shale oil being produced now all over the United States, actually all over the globe. So it's millions of cubic feet of this natural gas that's being flared. So what would be the long-term economic benefit from actually using this type of process that you have?
So if we could capture just a fraction of what's literally going up in smoke now, we could produce gigawatts of power. A gigawatt is 1,000 megawatts, and that would be a typical commercial power plant to run a major city, would be a gigawatt power plant. So we can take these locations throughout the world and turn them into power producing instead of just creating pollution, hot air, and additional CO2 for no benefit.
Now, looking at this, so many of these are actually in isolated areas. Many of them are not adjacent to the national grid, whether it's here or Nigeria or Saudi Arabia and other places. So what's going to be the way to capture all of this, then process it, and then actually put it into the grid or to the manufacturing facility directly so it actually has a long-term benefit?
Well, there are two things that we can do. In the short term, we can start reducing the flaring by using that as a substitute for the power that they're generating with diesel engines. So instead of trucking in diesel fuel over long distances with big trucks, resulting in fuel spills and the pollution from the diesel engines, we can actually use what's currently going into the flares to produce the local electricity. So that's a start. Over time, in order to capture these liquids, you have to put in tremendous amount of piping to be able to get the liquids to market if you're going to stop flaring them. But it's a lot easier to hang electrical wires than it is to construct pipelines. And so if we can put the power generation where the fuel is, then we can use electric lines to get them from some of these remote locations into the grid and into areas where people can use them.
So what you're talking about, Rick, is actually you produce this, and I understand you actually have some of your medium to even large size production equipment is on skids, where you can actually put it out and very quickly install and then be able to plug into, I guess, to the grid, or to then start using it on site at the fracking areas itself.
Yeah, some of our systems that are a combination of our LPP combustion skid and a gas turbine actually can be tractor trailer mounted, because as you know, these well sites move from time to time. You drill one well and then you move down the road and drill another well. So the demand for the power moves, and that would allow the power production units to move with them. And then over time, you can actually install some of these systems permanently and hook into the grid and provide ongoing power to the grid.
So looking at the system that we have here, is it difficult to do all of this, or is it very quickly as the wells move and the drilling starts? Actually, these skids can go with them and they very quickly can be reconnected and start producing almost immediately, or there's some lag time?
No, it can be done in very short order. There are commercial gas turbines from the tens of kilowatts up to the tens of megawatts made by major manufacturers that are already tractor trailer mounted, and we've designed LPP combustion skids that are also tractor trailer mounted that can go right along with them. So it makes these power systems mobile and makes them much more useful that way, to be able to follow the wells and follow the flare gases and take them and use them for power generation.
How does this benefit the driller themselves? They're on site, they're producing, instead of flaring now, they're all of a sudden using their own energy that's right there. So what is either the cost savings and then of course the benefit to the consumer and the environment?
Well, the cost savings is actually enormous, because right now to truck in diesel fuel over a long distance and then produce power with diesel engines generates a very expensive electricity. We, using the flare gas, which is essentially a free fuel because it's just going up in smoke, can reduce the cost of the electricity by about a factor of 3 or 4.
My goodness, you want to state that again?
Yes, so we can reduce the cost of the electricity at the well sites by about a factor of 3 or 4.
That's
so
incredible.
There's a huge economic incentive, but there's also other production incentives, because there's a lot of logistics involved in moving that much diesel fuel around and moving the diesel generators around. Because we're using fuel that's right there, we reduce what people would call the logistical tail and make it easier for the next well to be drilled and to be fracked and to be produced.
And then also at the same time, we're actually taking the burden off of the grid system as far as producing the diesel, which is being not only trucked in, but it's being brought from somewhere else. Much of it may be even imported into the United States. So there's a lot of benefits to all this. And then, of course, that goes to reducing the cost to the consumer.
So there are economic benefits, there are pollution consideration benefits, and the economic benefits are both in reduced cost and in better electricity for businesses and people.
Well, thank you very much, Rick Roby, President of LLP Combustion. Thank you as we create the Emerald